Kirkman. Hello and welcome to 7.1, where we're going to look at polynomials. So we are on our student companion page 138 and 139. And let's dive in. This is going to have a lot of vocabulary words to start, so get your pencil ready to take some notes. First, we need to understand what a monomial is. So a monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So if we come over here to this side, you can actually see some examples, which I think helps explain what a monomial is. So it's showing that it can be a number like 12, it can be a variable like x, or it can be a product of both, like 9 times a, or 5 times y to the third. Now, it does say that the variable have to have whole number exponents, so we can't have our fractional exponents, which would relate to radicals up here, and we can't have negatives either. We need whole number exponents. So these right here in green are monomials. Down here, or examples of in red, are not monomials. When I add two variables together, that's not a monomial. If I divide two variables together, if I add two variables and a product of numerals and a product of a numeral, here I have another division. These are not monomials, okay? And you may have understood monomial to kind of mean term. That's what we used to call them. The terms are the numbers that are between addition and subtraction signs in an expression. So here is a monomial, mono meaning one. Here's a binomial, bi meaning two. So there's two terms or two monomials. And a trinomial would be three. Okay. Of course, we're going to be talking about polynomials in this lesson, and a polynomial is basically poly means many. So it's just many nomials, many terms. Okay, so here we have 1, 2, 3, 4, okay, different terms. So monomials 1, binomials 2, trinomials 3, polynomial means more than 3, okay, many. All right, so monomial. What we need to understand about a monomial is what the degree of a monomial is. Okay, so the degree of a monomial is the sum of the exponents of the variables of a monomial. Again, all these vocabulary words, I like images. So I found this image here that kind of explains it's basically the sum of the exponents of the variables. And remember these whole number exponents. So here I have one exponent, which is a 3. So my degree of my monomial is 3. Over here, I have 3 exponents, 2, 3, and 1. And if I add each of those together, I get a degree of 6. Over here, I have a whole number, and that is what this first example is asking. It says, why does a constant, which is a number without a variable, have a degree of 0? Okay, well, why would it have that? It's because it doesn't have a variable. There's no variable here, so there is no exponent, which means that it has a degree of 0. There is no sum of its variables. And if we take a look over here at this side, it kind of explains the same thing. It shows here that here's the variable in the monomial 15x squared, has an exponent of 2, so the degree is 2. Here we have a monomial of 1/2 x to the 5th y to the 2nd. That degree will be 7. So therefore, if you have a constant with no variable, there is no degree. You can also think of it as having a variable with an exponent of 0, which means that it is itself 1, which means it's just 7, right? So 7 times x to the power of 0 is really just 7 times 1, which is just 7. So therefore, the degree of a constant is 0. Okay. So here we're going to look at this one. It says, why is 5 times x to the third minus 4 called a cubic binomial? Well, we know it's a binomial based upon the image we had before. Whoopsie, too far. Where we know binomials 2 terms, but why is it called a cubic one? Well, a polynomial is a monomial, or the sum or difference of two or more monomials called terms. Polynomials are named according to their degree. The degree of a polynomial is the greatest degree of any term in the polynomial. Greatest degree of any term. So because here this term is 3, that's the greatest one, it's called a cubic binomial because cubic for 3. All right, so here we have a monomial. Its degree is 0, and we call it a constant when it has no variables. Here we have a polynomial, and because this entire term has a degree of 1, it's called linear. Here we have another one. Remember, we're looking for the degree, for the greatest degree of any term. So we're just going to look at each term. So this term right here, the 3x squared, has a degree of 2. And this 2x is just 1. So we're going to go with the greatest one. And that is a degree of 2, which we call quadratic. Here, this is one whole term. So we're going to say that's 3 to the second power, or sorry, x to the second power is 2, and y to the first power is 1. 2 plus 1 is 3, so therefore this is cubic. And then any polynomial with a degree greater than 3 are just named by their degree, so like 4th degree, 5th degree. So because this term in the front has 4, we're going to call it a 4th degree. Polynomials are also named according to how many terms they have. And this is what we were looking at over here. So a monomial, binomial, trinomial, and if it has more than 3, we just call it a polynomial. So 5x to the third minus 4 is called a cubic binomial because it has a degree of 3 and it has 2 terms. That was a lot of information, but can you go ahead and name each of these polynomials based on its degree and number of terms? If you need to go back in the video and look at those two tables, go ahead and do so. All right, so example 2 takes us into writing polynomials in standard form. So in math, I always like to think of math as its own language. And when I think of math as its own language, it's because it has special rules and things that we do and the way we write things to help us understand math better. And one of those is the way that we write things. So the standard form of a polynomial is the form of a polynomial in which the terms are written in descending order. So going from largest to smallest according to their degree. We're going to rewrite the polynomials of this expression right here in standard form. So the first thing we're looking for is the greatest degree. So 6x to the 4th power, that is the greatest degree of 4, so it's going to go first. Okay, then we have x to the third, then we have x to the second, x, and then a constant with no x. So the standard form of this polynomial is as follows. So go ahead and take a chance to write each polynomial in standard form. You'll find that this is really useful later when we do a lot of things with our polynomials and our expressions. Having them in order will help us do things with it in the future. All right, now one of those things that we can do with polynomials is to add and subtract them and combine like terms. So we're going to learn about adding and subtracting monomials. So right here we have a problem that says, how can you use the properties of operations to combine like terms and write the expression 4x plus 3x squared plus 2x plus x squared plus 5 in standard form? So we're going to go ahead and take the like terms, just like you used to do previously, and we're going to find the ones that are the same and put them together. So here they're showing this is an algebra tile representing x squared, so like 3x squared, this would be 1x squared. We have x's and single units. So they go ahead and they're showing what the tiles would look like for each monomial and using algebraic algebra tiles. You can see here that the like terms have the same variables with the same exponents. So these x squares that are all blue and big and square, these can get put together because they are like. These single x's that are green and skinny and tall can be put together because they are like, and you'll see that in the video. It really shows how I can combine 3x squared and x squared, but I cannot combine 2x and x squared. Those are not like, I can't put them together. So you can see here that they are rearranging the tiles so that all the like terms are next to each other, and then that allows for easy adding later. And we're going to do that same thing without tiles when we're combining like monomials in the future. So this is the kind of neat and cleaned up version, and it's written in standard form. So here they're going to show you without algebra tiles how you can rearrange them. Okay. So you're going to go ahead and try that here, and like they showed in the video, okay, we'll just do a little bit of that over here. I'm actually going to rewrite this formula. So I'm going to write the x's squared next to each other. Whoops, see right there, I already made a mistake. Minus x squared. That's going to be my first thing I do. Then I'm going to subtract my 3x. Well, add my negative 3x plus 3x. And then I can put those things together and rewrite them. So go ahead and try them on your own. So the question here is, how is adding polynomials similar to adding whole numbers? Well, when I have a polynomial and I have lots of different terms and I'm adding a multi-term expression to another multi-term expression, it's very similar to adding something that has lots of place values. We want to line up those place values kind of like terms from ones to tens to hundreds. Just like here over here, we added up our constants, our linear polynomials, and our binomials. No, linear and what do they call the two? Oh, quadratic polynomials. Over here, basically, I'm just lining up my constants, my x's, and my x squared. And I can almost add them vertically, just like you do with place value, okay? Before you add polynomials, the terms must be aligned with like terms. This is similar to how, before adding whole numbers, you have to line them up according to their place value. So let's put that to use. So here we have two polynomials, two expressions that we need to add together and combine like terms. The first method is to actually add them vertically, like they showed in the picture before. Align the like terms. Notice that if there's no like terms, they just leave a blank. You could put a 0 in there as a placeholder if you wanted to. So that's method 1. Or method 2 is to add horizontally and to rearrange like we saw in the first video and what I did over here. I would say that this is probably my preferred method, although sometimes I prefer aligning vertically. It kind of depends on the expression and our main goal, but these are two different ways that you can do that. So whether you like aligning vertically or you like adding horizontally, go ahead and add these two sets of polynomials and write their answer in standard form. You can also subtract polynomials. When you subtract polynomials, if you do it vertically, you need to remember to distribute this -1 to all of the terms. If you do it horizontally, you would also need to distribute this -1 to all of your terms before you rearrange them. Basically, if you forget to distribute and rearrange them, then you're not going to make sure that this 3x squared is being subtracted, the 5x is being subtracted, and the -8 is being subtracted. So make sure you distribute that. The result of adding these together, the closure property states that polynomials are closed under addition or subtraction because the results of these is another polynomial. So go ahead and try to simplify these in standard form as well.